Hey everyone, my name is Joe. I'm with Grafana Labs, and today the promise was to talk about getting started with Tempo and to demonstrate an OpenTelemetry instrumented application that supports exemplars. And we're mostly going to be doing that, but things have drifted a little bit, and this presentation is kind of divided maybe into three sections now. We're going to talk about Tempo, as promised. We're going to talk about the state of open source exemplars and why what I initially said I was going to do for this session is not quite possible. But we'll still get to a demo in which we'll demonstrate exemplars in open source and talk about maybe where those are, why they're not quite available yet, and what it will take for those to kind of limp over the finish line and for us to all be able to use open source exemplars. So let's start with Tempo. Tempo is a new distributed tracing backend that we built at Grafana Labs kind of with this goal to sample 100% of our read path. So at the time we were sampling I think maybe 15% or so of our read path, and we often were having long queries that we wanted to diagnose. Maybe a customer was interested in why a particular query took a long time, or of course we are also interested in that because we want to understand why these queries are taking a long time and try to understand where that time is spent and how to reduce the latency on these calls. And the way we found to do that was simply by sampling 100% of our read path. We wanted to do this, but unfortunately with our previous backend we would have had to scale Cassandra or Elasticsearch to a point where the cost in memory or CPU, the operational cost, the cost to my sanity would have been far more than was worthwhile, especially for me, I think. But the size of this cluster would have just been, my whole job would have been managing Elasticsearch or Cassandra, which is not what I want my job to be. I want my job to be building Tempo, apparently, so we built Tempo. The solution is, Tempo, the thing we built, and we put, the difference here is Tempo's dependency, the only dependency of Tempo is object storage, so S3 or GCS or Azure, and these are of course cheap to manage. I mean, there's no management, right? These are managed services. It's very cheap to store very large amounts of data in these services and to use them. And so the goal here is to basically build a tracing backend on object storage only. The trade-off for now, at least, is that currently Tempo can only search by trace ID. I think the goal is, or at least the goal will be in the next versions of Tempo to support some sort of search, some sort of native search. But for right now, we only can do trace ID search. So you are going to only be able to ask the question, give me a trace for this trace ID. This may seem limiting, but at Grafana, we found many different ways to kind of get around this, and we'll talk about those in a second. We'll talk about maybe not even get around, but ways that we feel are very powerful ways to search for traces that do not require native search in your backend. So Tempo currently supports all major open source instrumentation libraries, Jaeger and OpenCensus, OpenTelemetry, Zipkin. So if you're already instrumented with anything like this, you can immediately start using Tempo without issue. We put things in S3 or GCS. And also Azure. This slide was made before Azure support was added, and I actually wouldn't even recognize these symbols anyway, but that red one is S3 and that blue one is GCS. And then we visualize everything in, shockingly, Grafana. Discovery. Okay, so you can only look up by trace ID. How do you discover traces? And right now the answer is logs. And we found we were doing this even before we switched to Tempo. We were often going through our logs to find our traces. So we would be logging on the same line as a trace ID. And this is standard request response style logging. Nothing new or weird about this, but log a trace ID, log a HTTP method, path, latency, status code, a bunch of common parameters or a bunch of common fields. And these now kind of effectively have built an index into our traces. An index we don't have to spend more money to build into our tracing backend, but instead can just use our logging system as it is. Now, Grafana we use Loki, and our demo will be Loki, but this works with Elasticsearch or Splunk or whatever you want to use. Also, exemplars are kind of the new upcoming feature that we're going to talk about a little bit in a bit here, the state of exemplars. But this new upcoming feature is a way to discover traces through your metrics as well. We'll talk more about what that means in a little bit. So, trace ID search only in Tempo. Currently, we use logs very effectively. We'll look at that in the demo, and hopefully in the future we'll be using exemplars. So where are we at? 380,000 spans a second or so. That fluctuates more than I care to admit. I wish it didn't fluctuate at all. I wish I could just push this higher and higher, but we're at 380,000 right now. We're at a little bit less than 7,000 traces a second. So if you do the math there, you can find out how many. I should have done that before I came here. Maybe about 60 or so. I could be totally making that up. Never mind. Ignore that. Traces, spans per trace is what I was trying to get to. But anyways, we have about 380,000 spans per second, about 7,000 traces per second, and our latencies are good. I'm very happy with this. Certainly, we can always push this down. In fact, recent additions to Tempo include the ability to scale the query front end or scale the query path. So we could actually reduce this by quite a bit if we wanted to. But right now, we're querying over 4 billion traces, and our P50 is around 400 milliseconds, which I'm very happy about. You can also see P90 is right around 500 milliseconds, and P99 kind of reaches up to 1 to 2 seconds occasionally. So very happy with these latencies. Always something to improve, of course, but I think this is well within operational expectations for a tracing backend. Architecture of Tempo. This is a little detailed. We won't get too into this. Don't be afraid to not understand all these pieces, but this is architected roughly like Loki or Cortex if you spent time with those open source products. So we have a distributor. The distributor handles replication factor, pushes our traces to ingesters. Ingesters then batch those traces up into blocks, and then these blocks are pushed into our storage backend, into S3 or whatever. We have this idea of the compactor over here on the side, and we are currently flushing, I think, something like 400 blocks an hour. So the compactor takes those small blocks and builds larger and larger and larger blocks. If right now we're doing what I'd say 400 blocks an hour, 24 hours a day, and we currently have a retention of 2 weeks. So 24 times 14 times 400 would be, without the compactor, our total block list length, which would require a lot of time to search. So the idea of compaction is to basically keep this, keep the length of this block list as short as possible in order to improve query performance. And then on the query path, we have this thing called the querier. Its job is to, ask the ingesters for recent traces and also check the backend. We have the query front end, which handles parallelization of queries and sharding of queries out. And this tempo query piece is hopefully going to go away soon. It's actually like a shim to translate to Jaeger, which is the only tracing backend that Grafana can handle right now. So that's why we're using it. In the near future, hopefully, Grafana will support Tempo directly. Okay, so that was a lot of things, and you don't have to know all those things to just get started, and this is supposed to be getting started. So check out these links here. Single binary deployment's important, so a way to just deploy Tempo not in distributor, ingester, query, all these crazy pieces, but instead to deploy it as a single binary to get started and to understand what it does and how to configure it. Tons of examples in these Docker Compose folder you'll see listed here. We have Helm options. There's a very simple Helm chart that I made that I think the Helm community would hate, but is kind of the way I would do a Helm chart. And we have a Helm chart that's being pulled, or a PR open now to have a more official, more robust Helm chart that I think meets the expectations of people who regularly use Helm. And JSONet set a blob of JSONet stuff as well to deploy. So all of these different deployment options, hopefully you can kind of dig into these, look through the Helm YAML, look through the Docker Compose, get a feel for what configuration looks like, and how to deploy this thing so you can get started working with Tempo on your own. Okay, so Tempo, it's our tracing backend. Discovery through logs and exemplars, high volume is the goal here. But exemplars is something we really want at Grafana, and we need to talk about where those are, because part of this presentation was supposed to be demonstrating those with OpenTelemetry, but we need to talk about why we can't actually do that just yet. So first, exemplars are a record of a single request, or an instance of a single request that was then aggregated away to create a metric. So the power of metrics is this aggregation, right? I can aggregate 1,000, 100, 10,000, however many requests into a very simple number, a single floating point. And if I do that, if I aggregate it all away, I can query these extremely quickly. I can provide, store them extremely cheaply and provide very powerful visualizations of my infrastructure. That is the power of metrics, but what's lost is the individual instances, the individual requests. And exemplars aim to kind of complete that picture, to take the aggregation, to display the aggregation and give you all that power, while at the same time letting you drill in and find a single instance of a request that was kind of used to create that aggregation. So where are we? Where are exemplars? Everybody wants, well, I want exemplars. Other people probably do somewhere. What's going on right now? Well, they're defined in open metrics. So the open metrics spec has a defined standard for exemplars. But that is not supported currently by OpenTelemetry, and in some of the issues I've read, they're not requiring it for GA. So I really just don't know exactly what timeline OpenTelemetry is looking at to support exemplars specifically. I believe they want full support for open metrics, so we are excited to see that, but it's not quite there yet. What about in Prometheus client libraries? So Prometheus client libraries support open metrics generally. Where is it there? Well, HappyCat knows that Go and Python is ready to go. So if you're using either Go or Python, if you're using either of these libraries or these instrumentation libraries, exemplars are available to you now. You can expose exemplars in an open metrics compatible format or in the literal open metrics format, which Prometheus would then scrape, store in its backend, and make available to a visualization layer. Java and Ruby have issues open. This unofficial .NET client also has an issue open. There's a lot of other Prometheus, a lot of other open metrics clients out there, and I encourage you to or if your library is not Go or Python, if your language of choice is not Go or Python, I encourage you to go to your current open metrics client library. If you're using Prometheus and using the .NET or the Java or whatever library or some other one, please get into those repos and request open metrics support. Let the maintainers know these things are important to you, and hopefully we can kind of all get together and all get support in these various client libraries for exemplars. So in the demo today, I'm going to use Go because Go already supports exemplars, and it'll be significantly easier. But what about our backend and what about our front end? So in Prometheus, there are 2 pull requests now that need to be merged for complete exemplar support. The first is an in-memory. In-memory support. So this first PR, when it is merged, will support an in-memory ring buffer, so an ephemeral storage of exemplars. So these are just kind of held for a short amount of time. It's basically however much time you, or basically based on the amount you're scraping and the amount of memory you give to the ring buffer. And then they're stored internally only, and when they're thrown away, they're just dropped. The second PR adds support for exemplars to the wall to store permanently, and then to remote write to push to a backend. So after that second one is merged, you would see support for exemplars hopefully start coming out in backends like Cortex or Thanos or some of these other kind of long-term Prometheus storage backends we're using. So the first PR, those of us who just use Prometheus will immediately be able to use exemplars. For the second PR, those of us who use Prometheus in combination with a permanent long-term storage backend, the second PR will kind of make it so that those backends can start recording, storing, and exposing exemplars. Okay, so Grafana, actually, support for exemplars is in the tip of master of Grafana right now, so soon, actually soon. For real soon in Grafana. I can't commit, of course, to anything. I don't work on the Grafana team directly. I don't dev with them. I don't do any of their milestones or project planning, but hopefully maybe like in 7.5 or some soon near future release, we should see exemplar support. Like I said, right now it is tip of master merged already, which is fantastic. Okay, so let's get to the demo and talk about instrumentation a little bit. So the goal here, again, was to do OpenTelemetry everything. And OpenTelemetry has a really compelling and very powerful server and client instrumentation setup. Very easy. Got my server here, right? So I just set up a new handler. I wrap my actual handler. So I have some HTTP handler. I just wrap it in this OTel handler, and then I serve the OTel handler out of my server, and then magic happens, and it's going to instrument my HTTP server for me. Same with the client side. So in this case, I'm just replacing the transport with an OTel transport. And in this case, my HTTP client is now instrumented. In this case, I'm worried about tracing, so context will be propagated correctly from client to server, and everybody will be happy. This is all going to work nicely. And with a very few lines of code, of course, there's also like boilerplate setup code to initialize the tracing libraries and get things set up. But for just kind of using an HTTP client, setting up a server, it's a pretty tight set of clean code. But OpenTelemetry doesn't support exemplars, so here we are. This is the demo you're about to see. Our metrics are going to be set up with OpenMetrics and Prometheus, and our traces are going to be through OpenTelemetry and Tempo. So Tempo is our backend, OpenTelemetry is going to be our instrumentation library, and then OpenMetrics or Prometheus is going to be our metric side and then stored in Prometheus. And the reason is because OpenTelemetry just doesn't support exemplars yet. And you can find this example kind of at the link there at the bottom, GitHub, Joe Elliot, tracing example. Cool. So, to the demo. So this is Grafana. This is a build off the tip of master, which is why, or is a build off the tip of master. So this is not something you just pull in a Docker container or just install. It's not GA or anything. Like I said, hopefully support for this will exist soon. I'm querying Prometheus. So this is this Prometheus is a image from actually Callum's branch. So Callum Stian is had the 2 PRs. He's the maintainer who submitted the 2 PRs for exemplar support. So the Prometheus image I'm using is just one of his personal images. You can see it. There's a Docker Compose. So this is, again, a open repo. It's a GitHub repo. Please go check it out. And you can see in the Docker Compose exactly what images I'm using. So there's nothing like hidden here. There's no tricks. This is actually all working. So I'm asking, like, this is a normal. Maybe I should zoom in a little bit. Maybe a little bit. So this is a normal histogram Prometheus query P99, and what's being returned along with the normal return. The normal return is the metric, and this is actually a little crowded at the moment, but you can see these exemplars as well. So I see my trend. I can also go over here and click on a exemplar. I can choose one of these, and I can immediately jump over here to a trace. So I have my metric. That metric is a ton of requests that are all aggregated up into a single request. And I can then use this new exemplar support in OpenMetrics and in Prometheus, hopefully very soon, to store an example of a single request. And then here I can, dig in my trace, and this is all normal distributed tracing for those of us who have played around with this. Cool. So exemplars are kind of this new upcoming feature. Talked about all the different places that it would be available soon. Hopefully, cross your fingers. Like I said before, Tempo is also dependent on, Tempo is also dependent on this search. It's also dependent on logs for discovery. So this is the way we actually discover logs right now, and this is a Loki query. As discussed, doesn't find anything. Maybe I can. As discussed, this is Loki, but this is compatible with. Is it there? Oh, yeah, okay. We're just in a weird spot. So this is compatible with Elasticsearch or any logging backend where you can build a link from like an ID. This is going to work. So there's no like dependency on any, on Loki or anything else like that. But to show you what we do in Grafana, so you can see here I have the, the path recorded. I have the latency down here. I have the trace ID. And I probably should have other things, of course, like, the HTTP verb, status code, and other information. If I put all these on a single log line, I can then do some really clever queries like this. Like, let's look for something over 2 seconds, maybe. Yeah, so now all of these traces are greater than 2 seconds, and I am now interested in maybe some long-running traces so I can diagnose some kind of latency issues. If I were more clever and had, like, let's say method equals get, and I could do another pipe and do something like status equals 500 if I was interested in failed queries or whatever. So with some careful logging, I can create, and this is normal HTTP request logging, so a lot of us already have these logs. I can build basically an index into my traces that lets me do advanced searches and can also discover traces. So let me jump over here, boink, and I should be able to get, a trace out of this log line. And it's greater than 2 seconds like I asked for. Cool. Okay, so Tempo is this new, like I said, distributed tracing backend designed for high volume, extreme volume, and it's designed to be inexpensive and cheap to run. Put everything in S3, put everything in GCS. Don't have to bother with complicated backends. In exchange, we're doing Trace ID search only, at least for now. And like I said at Grafana, we're doing this kind of log-based lookup of our traces using Loki. Again, you can use whatever you want. This discovery through logs allows us to store traces super cheaply, super inexpensively. And then soon, hopefully, we're going to see exemplars like we were digging in. Only supported by some clients. Support for Prometheus has 2 PRs up. Once merged, we'll have complete support. Grafana has support in the tip of master. So we're real close to the point where we should start seeing open source exemplars in all of our favorite, metrics tools. We also used open telemetry for the demo application. So if you want to dig into the code, and we showed some example code there. And then we had to kind of use also open metrics in order to get exemplar support. Definitely looking forward to when OpenTelemetry has full open metric support, including exemplars, and we can use the OpenTelemetry instrumentation. Thank you all for your time. I think we're going to do Q&A in a little bit, but thank you, FOSDEM. Enjoy your conference.